In last lecture, we have seen what is the origin of graph theory and why there is a need to study the graph theory. Let us see the definition of graph. Before going to definition, if suppose we have to draw some diagram, then what should we have to do? Suppose they are in a hockey league, in a hockey league, suppose there are 8 teams. Suppose there are 8 teams, namely STU, STU, D, W, X, Y, and Z. After a few weeks of season, the following games have been played. Suppose yes, he has played with yes has played X and Z. Y has played Y has played W, yes, and Z. Sorry, S has played X and Z. E has played W, X and Z. U has played Y and Z. V has played W and Y. W and Y. W has played T, V and Y. X has played S and T. Y has played U, V and W. And finally Z has played S, T and U. Now suppose we have to illustrate all this situation in a one diagram, then what to do? Let us take these teams as a dot. For example, take these 8 teams as a dots in a diagram. 1, 2, 3, 4, 5, 6, 7, 8. These 8 dots are 8 teams. That is T, S, T, T, U, V, W, X, Y, and Z. Now we join these dots if the corresponding teams have been played with each other. Then S has played with Y and Z. S has played with sorry. S has played with X and Z. So we have to join these 2 dots. Now, T has played with W, X and Z. T has played with W, X and Z. U has played with Y and Z. U has played with Y and Z. V has played with W and Y. V has played with W and Y. X has played with S and T. X has played with S and T. Y has played with U, V, W. Y has played with U, V and W. And Z has played with S, T and U. Z has played with S, D, and U. So this is the corresponding diagram of the hockey teams. Now we can draw this diagram also in this way. These are the 8 teams. Here's D, U, P, W, X, Y, and Z. Now we take this as yes as related to Z and years. And we can draw this in this way. This is a graph G1 and this is a graph G2. So there are two possible diagrams of this place. Now let us see what is the actual definition of a graph G. A graph G consists of two sets. A graph definition of our actual graph G. A graph G consists of two finite sets, two finite sets. One is vertex set of a graph G and one is edge set of a graph G. This vertex set of a graph G is always non-empty, and this edge set of graph G, it is maybe empty. The vertices of a graph G are also called as nodes, points, or just simply dots. And the edges of a graph G are represented by either by a straight line or curve. Edges of a graph G are represented by either on a straight lines, that is straight lines, or curve. Now, and each edge of a graph G corresponds to an ordered pair of vertices U and V. Suppose some E is an edge of a graph G, then this E is corresponds to two unordered pair of vertices Vi and Vj. That is, E is edge joining between these two vertices. Now, what is null graph? Let's see what is null graph. If edges are upset in a graph, then the graph is called null graph. That is, the edge set of a graph G will be equal to n. For example, let us take one graph V1, which is V2, V2. This graph G has three vertices, but there is no edge. Hence, this graph G is a null graph. Now, what is loop? Loop. A vertex of a graph G, vertex of a graph G, is joined to itself by an edge, by an edge, then this edge is called, then this edge is called loop, or also self loop. That is, if a vertex of a graph G is joined to itself by an edge E, then this edge is called a self loop. For example, it is drawn graph. Suppose this one is graph which has four vertices V1, V2, V3 and V4. Okay, and if these are the edges E1, E2, E3 and E4. Now here is one edge E5 which is joined to vertex V3 to itself by an edge E5. Then this edge E5 is called. Now the next point is, what are the parallel edges? Parallel edges. Two edges of a graph G. Two edges of a graph G are called parallel. Parallel. If the end vertices are same. If the end vertices of these vertices of these two edges are same. For example, suppose this one is a vertex V1, this one is vertex V2, this one is vertex V3, and this one is vertex V4. This one is V1, V2, V3, V4, V5. So from V2 to V4, there are two edges. Then these two edges are said to be parallel. That is, the E4 and E5 are the two edges whose end vertices are same. Hence, these two edges E4 and E5 are parallel. Here, E5 and E4 are parallel edges. Parallel edges. But E2 and E3, E2 and E3 are not parallel. Since now, let us see what are the adjacent edges. Adjacent edges. Two edges, incident on a same vertex V, are called adjacent edges. For example, G. 1, 2, 3, 1, 4, 5, E6. Now, here edges E1 and E2 are adjacent edges since they are incident on the same vertex V1. Similarly, edges E2 and E3 are adjacent. Again, these are incident on the same vertex V2, but edge E2 and E4 are not adjacent edges. Okay. Now, what are the adjacent vertices? Adjacent vertices. Two vertices, two vertices of a graph G, of a graph G are called adjacent vertices. Adjacent vertices. If there is an edge joining between these two vertices. These two vertices. What are the adjacent vertices? If two vertices of a graph G are said to be adjacent vertices if there is an edge joining between these two vertices. The adjacent vertices are also called as neighbors. Called as neighbors. Let's see what are adjacent vertices. Here is our graph G. Here, V1 and V2 are adjacent vertices since there is an edge joining between these two vertices, which is an edge E2. Similarly, V1 and V4 are adjacent vertices. V1 and V3 are adjacent vertices. In this graph, each vertex is adjacent to another vertex. Let us see another graph G. V1, V2, and V2. Here, V1 and V2 are adjacent vertices since there is an edge joining between these two vertices. Similarly, V2 and V3 are adjacent vertices since there is an edge joining between these two vertices. But V1 and V3 are not adjacent because there is no edge between these two vertices. Now, there is one important note. Crossing point or point of intersection will not be considered as a vertex. Will not be considered as a vertex. That is, suppose this one is a graph. Then there is a point of intersection between two edges E4 and E5 and E6, but this point of intersection will not be considered as a vertex. Okay, now what should be the degree of a vertex? Degree of a vertex. Degree. The number of edges, the number of edges incident on a incident on a vertex V are is called the number of edges incident on a vertex V is called degree of degree of vertex V, and it is denoted by and it is denoted by for example, this is a graph G. Now we have to find out the degree of each vertex. Degree of vertex V1 will be equal to degree of vertex V1 will be equal. What is the degree of vertex? The degree of a vertex is nothing but the number of edges incident on that particular vertex. So here there are two edges which are incident on a vertex V1. Therefore, the degree of a vertex V1 is 2. Similarly, degree of a vertex V2 will be equal to, as there are 4 edges incident on a vertex V2, therefore degree of V2 is nothing but 4. Degree of V3 is equal to 2. Degree of V4 is equal to 3. And degree of V5 equal to 3. Okay. Now, let us see what is the isolated vertex. The isolated vertex. A vertex of degree 0, a vertex of degree 0 is called isolated vertex. In this graph G, there is no isolated vertex since each vertex have a degree greater equal by 2. So let us see one another example of the graph. Here, degree of V1 is 2. Degree of V2 is also 2. Degree of V3 is also 2. But the degree of V4 and V5 will be 0. So, vertices V4 and V5 are the isolated vertices. Now, let us see what is the pedant vertex. Pedant vertex. A vertex of degree 1, a vertex of degree 1, degree 1 is called isolated, is called pedant vertex. vertex. Let's see the example. This is a vertex V1, vertex V2, V4, and vertex V6. Here, degree of V1 is 3, therefore vertex V1 is not a pendant vertex. Degree of vertex V2 is 2, therefore vertex V2 is not a pendant vertex. Similar, but degree of vertex V3 is 1, therefore this vertex V3 is a pendant vertex. Pendant vertex. Similarly, degree of V4 and V5 are not pendant vertices since the degree of vertices V4 and V5 is greater or equal by 2. But vertex V6 has a degree 1, then vertex V6 is again a pendant vertex. One. Now, we have seen what is a loop. So, we note a loop of a graph contributes 2 degree, that is the degree of a loop is always 2 if there is one loop at vertex P4 which is an edge, E7. Then this edge E7 has two ends, which is starting from vertex V4 to V4 itself by an edge E7. Then this loop contributes 2 degree.